Alright, welcome back everybody. We're going to talk about the triangle inequality theorem today. The first thing you need to know is what the triangle inequality theorem is. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. You might want to pause the video to take a moment to write this down. What this means is that the sides have to be a certain length so they're going to be able to reach each other. So let's take a look at this first piece. If I've got one of length 3 and that comes down, it's going to hit right about here, but if I've got one of length 2, that one's only going to come down here. It's not going to be big enough. The two sides are going to fall in on each other. Similarly, if I've got one of length 3, that one's going to fall down right in the middle, and so is the other one of length 3. It's going to fall right down in the middle. There's not enough to hold them up together. The only thing that's going to work is if I have one that's 4 and one that's 3. So 4 plus 3 has to be bigger than 6. That means there's only one situation where you can have a triangle. The sum of either of the two sides has to be bigger than the greatest length. So I'm going to take the biggest one, and if the sum of the smaller ones is bigger than that, that's the only time I'm going to get a triangle. What the triangle inequality theorem says, another way to look at it. We're going to talk about sides. So if AB and AC, by the way, this picture is not drawn to scale. So I could talk about AB and AC. If I could add those two sides together, they have to be bigger than the third one. I could talk about AB and BC, would have to be bigger than AC. Or I would talk about AC and BC would have to be bigger than AB. So again, this one right here, let me get a different color so you can actually see that. Let's go with blue. This one would have to be the biggest side. Now I'm purposely not drawing triangles for all of these because sometimes you're going to see this on a test and the triangle is not drawn to scale. So you have to also be able to read along using the pictures. So if I look at, for example, here on my triangle, I've got one side that's 3, one side that's 5. If I look at that, that's going to tell me that the biggest side is opposite the biggest angle. The medium side is going to be opposite the medium angle, and the smallest side is going to be opposite the smallest angle. So if I look at the 5 and the 3, I have to go opposite. So I'm going to go draw a line across from here. That would be that opposite side. If I draw a line across from C, that would be that opposite side. If I draw a line across from A, that would be its opposite side. So if I look at 5 versus 3, which one's bigger? Well, the 5 is. Since the 5 is bigger, that means that angle B has to be bigger than angle C. The converse is also true. Converse means opposite. So biggest angle. The biggest angle would have to be opposite of what? The biggest side. The medium angle would have to be opposite of the medium side. And the smallest angle, you got it, is opposite the smallest side. So for another example, again, I'm going to draw my arrows so I don't forget. Angle C goes right across to side AB. Angle B goes across to side AC. And angle A goes across to side CB. If I look at that, that tells me, I'm going to see if I can figure out what is the biggest side, what's the smallest side, and what's the medium side. Now notice I've got a triangle, so any three sides of a triangle have to add, or sorry, any three angles of a triangle have to add up to 180 degrees. So if I take 180 minus 30, gives me 150, minus 60, minus 65, that's going to give me 95. So this is going to be 95 degrees up here. That's angle A. Since angle A has 95, that means the CB is going to be the biggest. Since angle B is 65, that's in between 30 and 95, that's going to be the middle one. And since angle C is only 30, that's the smallest of three angles, so AB has to be the smallest side. I'll give you a second to write that down. Finally, let's figure out where we can use this. we're going to list the measures of the sides of the triangle in order from least to greatest. Least means smallest. Greatest means biggest. Notice they put a very, very important thing in here. It says this picture is not drawn to scale. So even though it looks like angle A would be the biggest because it looks like BC is the biggest, we don't know that. We have to actually use our angles to figure that out. Now the only thing that we know about any angles of a triangle is that they have to add up to 180 degrees. So we're going to use that to solve for x. We're going to add all three of these together. We're going to have A plus B plus C, and we're going to add them up to be 180 degrees. We're going to combine our like terms, so 2x plus 4x and 1 minus 11 to get 10x minus 10 equals 180. We're going to subtract both sides by 10 to get all the numbers on one side, and then we're going to divide both sides by 10 to get x by itself to get x is 19. Now we're going to take that x is 19 and we're going to plug that back into each one of those. So in order to find A, I have to do 2 times 19 plus 1. To find B, I got to do 4 times 19. And to get C, I have to do 4 times 19 minus 11. If I do that, that's going to give me A is 39, B is 76, and C is 65. So I'm going to plug those in so that I know what my picture looks like. I've got 39, 76, and 65. Again, we've got to figure out which one is the biggest. The biggest one is B, so if I draw that across, B goes to AC, that's the biggest. That's not the right order I want to go in. So let's go back up here. It says from least to greatest. Least to smallest, so let's start with the smallest. That's this one, 39 degrees. If I draw across from that, BC is the smallest. The middle one, draw across from the middle angle, that is AB, and then we're going to do the biggest angle is B, so that's AC across. Therefore, just as we said, BC is smaller than AB, which is smaller than AC. Our next example is going to be to say to solve the inequality if AB plus AC is bigger than BC. So that tells us that BC should be our biggest side. All I'm going to do is I'm going to plug and chug. So AB is right over here, that's my x plus 2. I have AC over here, that's my x plus 3. And I have BC over here, it's my 3x minus 2. So if all I do is plug in, AB is x plus 2 plus AC is x plus 3 greater than BC is 3x minus 2. Now I'm going to combine like terms, so I'm going to get 2x plus 5 is greater than 3x minus 2. I'm going to solve this just like I would if it was an equal sign. So I'm going to subtract 5 from both sides, get all the numbers on one side. So I've got 2x is greater than 3x minus 7. Subtract 3x from both sides. I'm going to get negative x is greater than negative 7. The only difference here is when I divide by a negative 1, I have to actually flip the inequality. So when I divide by the negative 1, I'm going to get x is less than 7 for my answer. And that's my answer for this one. Finally, I need to determine if the following lengths of the sides are legs of the triangles or not. So we talked about this a little bit. So what we need to do is we need to follow our triangle inequality theorem way back from our first slide. So what I need to do is we're going to choose the smallest two of the three sides, and then we're going to add them together. We're going to compare them to the sum of the third side. So if we look at the first one, 4 and 5 are the smaller ones, 9 is the biggest one. 4 and 5, that has to be greater than 9 from our triangle inequality theorem. Now is 9 greater than 9? Of course not, it's equal to it. Since 9 is not greater than 9, that is not a triangle. So no triangle. Sad face. Let's look at the second one. Pause and see if you can solve it. Now again, we're picking the smallest two sides, so 5 and 5. I'm going to compare that to 9. Is 10 bigger than 9? It is. Since it is, we have a triangle. So yes. Whoops. I don't know what that happened there. But yes, we have a triangle. Yay! Happy face. Finally, if I have a triangle whose side lengths are 6 and 12, what are the possible lengths of the third side? So again, we're going to use the triangle inequality theorem. We've got a couple of different options. Now, this could either be the length that is between, so it could be like a middle length and the 12 could be the biggest one, or the 6 and the 12 might be the middle one and then the x could be the biggest one. So if I could take 12 plus 6, that's going to give me 18. That would give me, something's got to be bigger than 18, remember? But if I do 12 minus 6, that would be something less than 6. Therefore, it could be between 6 and 18. Because remember, if it is 6, then I would have 6 plus 6 could not be greater than 12. And if it is 18, then 6 plus 12 is not greater than 18. That's why it has to be bigger than 18 and less than 6. So another way to look at that is x is less than 6 and x is bigger than 18. Alright, that's all for now. Now it's time for you to work on M4 and M5.